Okay, so now we're going to see what do we do when our sample size is small. And small in statistics is less than 30. In that case, the sample standard deviation does not give us a good estimate for the normal distribution. So we're going to need to introduce a new distribution known as the t-distribution. So the t-distribution, when the population standard deviation is known and the sample size is less than 30, then the t-distribution follows this distribution here, the sample mean minus the population mean over the sample standard deviation divided by the square root of n. And the critical values, though, are found. It's really a little simpler to find them for you in this class because we have a table that's included in the tables that's included in your e-text called the t-distribution table. And we'll see how to use that in just a minute. The t-distribution is also bell-shaped and symmetric about the mean, just like the normal distribution, but it is a little wider and shorter, and it has a parameter known as degrees of freedom. Degrees of freedom is the sample size minus 1. And the total area under the curve is still 1 or 100%. The mean, the median, and the mode are all equal to 0. Again, just like the normal distribution. And as the degrees of freedom increase, as the sample size gets closer and closer and closer to 30, the t-distribution gets closer and closer and closer to the standard normal distribution. So, for example, suppose degrees of freedom is 2, which remember means that the sample size was 3. You see how it's got very high tails and it is fairly short. Now, if we increase the degrees of freedom, the tails start dropping down and it starts getting taller. And then if we go all the way up to degrees of freedom being 30, then we're talking about it's following almost exactly the standard normal, which is a taller, thinner bell than the t-distribution. So let's see how to use that table. Let's find the critical values T of C for a 95% confidence interval when the sample size is 15. Well, if the sample size is 15, then the degrees of freedom is 14. Degrees of freedom are along this column here. Find degrees of freedom equal to 14 and read across this row. We're looking for a 95% confidence level. The only choices we have for this table are 50% confidence levels, 80%, 90%, 95%, 98, and 99. For 95%, that critical value is 2.145. So easy to find, almost easier than with the standard normal table. All right, so the idea looks the same, right? We still have confidence level of 95% here in the middle, and our critical values are symmetric about 0, so it's plus or minus 2.145. Then once we find, and the formula for the margin of error is almost exactly the same margin of error formula we saw in 6.1, except the critical value is now a T of C instead of a Z of C. And other than that, we find it the exact same way. So first thing you need to do is find the sample mean. Then you identify the degrees of freedom, which is the sample size minus 1. Find the margin of error, which is the critical value times the standard deviation over the square root of n. Then add and subtract that from the sample mean, and you get the left and right endpoints for our confidence interval. Let's look at an example. Suppose we randomly select 16 coffee shops, and we want to know what's the average temperature of a cup of coffee in all coffee shops. Well, we sampled these 16 so we can find the sample mean, which was 162, and the sample standard deviation of 10. Let's find the 95% confidence interval for the mean temperature. Now notice, they did not give us the population standard deviation. We're using the sample standard deviation, and the sample size is less than 30. So that tells us that even though the temperatures are approximately normally distributed, which they had to be to even use the t-distribution, then we can use our table, and degrees of freedom is 16 minus 1 or 15. Go to 15, find a confidence level of 95, and it's 2.131. So the margin of error is 2.131 times 10 over the square root of 16, which is approximately 5.3. Add and subtract that value from the sample mean of 162, and we get a lower limit for our 95% confidence interval of 156.7 and an upper limit of 167.3. So we think the average temperature of all coffee shop coffees is somewhere between 156.7 degrees and 167.3 degrees with a 95% confidence, right? So when do we use the normal or the t-distribution? This flow chart is in your e-text, or it's also here on this PowerPoint. It's a good PowerPoint to kind of star, and so you can look at to decide whether we're using the information we learned in 6.1 and using the normal distribution, or this information we're learning right now in 6.2 and using the t-distribution. The first question to ask is n greater than or equal to 30. If that's the case, you're definitely using the normal distribution. You're doing this using the standard normal table and finding a z critical value. If the answer is no, then you need to ask yourself, is the population normally distributed or at least approximately normally distributed? If the answer is no, then you have not learned how to do this and you just say, I don't know how to do this. But if it is, and then you have to ask yourself, is sigma, the population standard deviation, known? If the answer is yes, then again, it's back to the normal distribution. If the answer is no, that's the whole point of what we're learning now. It's the t-distribution. Let's decide if this is a normal distribution, a t-distribution, or neither. 25 homes, okay, question 1, is the sample size greater than 30? No. So then we've got to ask ourselves, is the distribution normally distributed? Yes, assuming construction costs are normally distributed. So now we have to ask ourselves, is the population standard deviation known? Yes, it is. It says the population standard deviation is 28,000. So then our answer is the normal distribution. All right, that's the end of 6.2, and that's all we're going to look at in chapter 6. 6.3 and 6.4 are doing the exact same procedure, but for two other parameters, the parameters of a population proportion or a population standard deviation. And we're not going to cover it in this class, but you can look at, if you're interested, you can read section 6.3. And the procedure is still the same. You find the point estimate, you find a margin of error with a formula, and you add and subtract it from your point estimate to get the lower and upper limits for your confidence interval. Now it's time to go do your homework for section 6.2, which is found on the Course Compass website in the My Math Lab.